Data connection is one of the most important applications in all of Foundry because it's the primary way you get data into and out of the platform. In this tutorial, I'm going to take you on a brief tour of data connection, explaining its core concepts and showing you realistic examples of how it's used. The two main concepts of data connection are sources and sinks. Sources represent external systems that Foundry can exchange data with. For example, a database, a CRM system, a data warehouse, an ERP system, file storage, a REST API, and so forth. Foundry connects with many different types of source systems out of the box, and it supports custom connectors when required. When you add a source to Foundry, you're saving the connection details that specify how that source in Foundry should exchange data. You're also determining who within your organization has permission to access that source and the data that comes from it. Without getting into the details that differentiate one particular type of source from another, there are two broad categories of sources: direct connections on the one hand and agent-based sources on the other. Let's talk about direct connections first. Direct connection sources are for any source system that can be accessed over the internet, which is probably most modern enterprise software services and data infrastructure today. I suggest using direct connection sources whenever possible. For example, one of my sources is Snowflake. That's where I have all the operations data for the imaginary Ontologize theme park, whose data you'll see later in this tutorial. Since Snowflake has a pre-configured connector, I just follow the setup wizard to get access to my data. It's pretty straightforward, while still giving me access to more advanced configuration options if I need them. If I needed to connect to an external system that doesn't have a pre-configured source type, I would either pick one of the generic source types, such as JDBC in the case of a service like Snowflake, or create a custom source. The other type of source is an agent-based source. Agent-based sources are primarily for when you can't or don't want to expose a system to a public network. An agent is a program that you download from Foundry and run within your own infrastructure, whether that's on-prem, a hybrid cloud setup, or a VPC. Foundry doesn't communicate directly with agents. Instead, an agent pulls Foundry for instructions and pushes data to Foundry. This gives you maximal control and security, with the trade-off that there's more overhead to manage. Here I've got an agent running in an Azure VM, directing data from a Kafka cluster to Foundry. In this case, it's sensor data coming from rides across the theme park. Think like a temperature sensor on the station brakes of a roller coaster. Foundry tracks whether the agent is healthy or not, and gives me metrics of data like disk space, CPU utilization, agent uptime, things like that. I also get logs, and I can adjust agent settings as needed, including things that affect data transfer rates and maintenance windows. So in one sentence, direct connections and agent-based sources are there to let you connect to any external system that you need to, and apply access controls to your data from the moment it's indexed in Foundry. However, just setting up sources is not going to get your data into Foundry. For that, we need to talk about sinks. A sink is a set of instructions for how and when to pull or push data into Foundry. Each source can have multiple sinks. Let's take a look at the sinks from my S3 source. You can see that I have two sinks right now. If we want to add more sinks, we can go to Explore Source, which lets us examine the files in this bucket, and then we can sync either individual files, as I'm doing here, or we could sync a folder, or we could sync the entire bucket. If we go to edit one of these syncs, we can see that for rides.json, I've set it up to run daily at midnight, that it's a snapshot sync, which means it will overwrite existing files in Foundry whenever it runs, and that it will only run for files that are new or have changed since this sync last ran. In contrast, if we look at the syncs for the Snowflake data source, we can see they're different. For one, these syncs are for tabular data instead of files or folders, and for another, they're using append transactions instead of snapshots. This means they'll only add to the data that's already in Foundry. Finally, they're incremental syncs, meaning they're only going to ship the new rows instead of the entire table. Finally, the streaming sync just runs continuously unless you pause it. Each sync will produce a dataset, or in the case of streaming syncs, a stream, which for our purposes is very similar to a dataset. For example, here we're looking at the dataset for the S3 bucket sync of rides.json, and it has a single file in it. Here's the dataset produced by the sync for guest rides from Snowflake. Instead of indicating they're updated by code or some other transform and that their inputs are datasets, these datasets indicate that they're updated by the sync and data connection and their inputs is the source that sync belongs to. If you've written data pipelines in Foundry before, you may be starting to see a parallel between sources and input datasets and syncs and transforms. And indeed, that parallel carries forward to how you track the progress of a sync, which is in the Builds app, also known as Job Tracker. Here we can see that my streaming syncs are running. And if I manually kick off a sync of the guest rides table from Snowflake, it appears here too. Okay, now that we've seen what sources and syncs are and how they work, let's take a look at them in the context of a data pipeline. This is the view of a data pipeline. A couple related pipelines, actually. On the right, we have objects in our ontology, which are backed by the data we're syncing from external sources and then transforming using Foundry's data engineering tools. On the left, we have the sources, which, again, in this case are Snowflake, S3, and a Kafka stream coming from the sensors on the rides in our theme park. The datasets created by the syncs appear as data extracts, and the stream appears as a data connection task. I then transform all this data with Python, SQL, and Foundry's no-code pipeline builder tool. If I open up the schedule for a downstream dataset, let's pick rides clean, I can see that the datasets created by the sync are marked as input trigger datasets, which means that when there's new data from either of these syncs, the whole pipeline will run. As an aside, it's usually best to avoid having multiple dataset extracts from different sources be the input triggers for a single pipeline. This is because whenever either of those sources brings in new data, it'll cause your whole pipeline to run. If, for example, you only need that N dataset to update once a day, and each sync runs once a day, well then your pipeline's probably going to run twice, thereby using twice as much compute as you actually need. Now, in this case, I know that rides.json will rarely update, so I'm okay. Now, you may have noticed that there's one other source here on the graph not connected to the pipeline. I did that one manually. In most respects, it's no different from any other source. What does make it unique is that it doesn't have any syncs. Instead, it's got a webhook. Let's take a look. Webhooks let you call an external API endpoint whenever something happens in Foundry. Today, that looks like rigging up an action in your ontology to call the webhook when, for example, an object monitor is triggered, or a Foundry rules alert is fired, or a user clicks a button in an application that runs the action. Here, I've got a webhook set up to send text messages via Twilio's API. I've got an object monitor that watches for low ridership across all the rides in the park, and when it detects a dip, it will use this webhook to send a message to the supervisor responsible for that part of the park so that they know there might be an issue. There are a lot of use cases for webhooks. For example, creating a work order in your ERP or CMMS system when a model predicts that a piece of equipment will need maintenance soon. Or sending data to some externally hosted system for processing and receiving the result for subsequent use in Foundry. Like syncs, webhooks rely on having a source set up. Unlike syncs, they're always on demand, not scheduled, and they're better suited for one-off individual tasks rather than bulk data transfers. Webhooks are a good segue to our final topic, network egress policies. You see, Foundry is pretty locked down by default, which means that you can't make requests to external systems without previously permitting those requests with network egress policies. Each source requires one or more network egress policies. This can be a little confusing at times, but Data Connection will do its best to help you based on what information it has available. For example, when I was setting up the syncs for the Snowflake source, I needed to add additional network egress policies to make them work. Data Connection had a suggestion for where I could go to understand what additional domains I needed to add. Alright, that wraps our tour of Data Connection. I hope you found it useful. There's obviously a lot more that we could talk about, especially when you get into the details of setting up sources and syncs and creating schedules for your pipelines. I'll be covering all that in much more detail in my upcoming course, Data Engineering with Pipeline Builder. If you're interested, I'll be sharing updates on this channel and LinkedIn. In the meantime, let me know what else you'd like to learn about Foundry, and I'll see you in the next tutorial.